warm welcome to the module on Gaylussacs law. So far we discussed the relationship between pressure and volume, that is Boyle's law, and volume and temperature, that is Charles' law. Now let us discuss the relationship between pressure and temperature. You all please watch the video and find out the relationship between pressure and temperature. Here you can see that as the temperature increases, pressure of the gas is also increasing, keeping the volume and amount of substance are constant. So here you can see two variables, that is pressure and temperature, and other two constants, that is volume and amount of substance. So the relationship is, on increasing temperature, the pressure of the gas is also increasing. This relationship was given by Joseph Gay-Lussac and is known as Gay-Lussac's law. Now we can represent Gay-Lussac's law mathematically. Let us recollect one thing. What is the proportionality between pressure and temperature? Yes, here the proportionality is direct proportionality. Which letters can be used for representing pressure and temperature? Yes, here P is denoting the pressure and capital T is denoting the temperature. So we can represent Gay-Lussac's law as P proportional to temperature. We can change the proportionality by a constant and it becomes P by T is equal to a constant. This is the equation for Gay-Lussac's law. P by T equal to constant. Now let us consider the expansion of gases on increasing temperature. Let P1 be the pressure at temperature T1. On increasing the temperature T1 to T2, the pressure becomes P2. We can apply Gay-Lussac's law in this case. You have already applied this type of relations in the previous cases. So what will be the equation for the state 1? Yes, it is P1 by T1 equal to constant, and for the case 2 or state 2 we can write it as P2 by T2. So the final equation is P1 by T1 is equal to P2 by T2. As in the case of Boyle's law and Charles' law, we have to try to draw a graph for this Gay-Lussac's law also. This graph is connecting pressure versus temperature, and we know that pressure is directly proportional to temperature. So the graph will like this, and we can found that the graph is plotted at constant volume. A graph plotted at constant volume can be called as isochore. Hope you all understood about the Gay-Lussac's law. Thank you dear students. We will meet in the next